those stars have their own planetary systems. Our solar system with its 8 major planets is not alone. There are other brethren planetary systems out there by the billions.
Of course, astronomers hope to find another solar system with a planet like Earth, and they're off to a good start. So far, Marcy and other astronomers have discovered over 360 stars with orbiting planets.
One of the exciting discoveries that we've made is that stars tend to be orbited not just by one planet, but usually 2, 3, 4, or a multitude of planets. Planets come in families, not unlike the family of planets we enjoy here around our own sun.
For the first time, scientists can study them in some detail.
We can actually observe how planets heat up as they go around their sun. For example, we actually saw that one planet got hotter and colder as it orbited its star. And we realized that we were actually seeing the night side of the planet and then the day side of the planet. That was a temperature difference. We were observing sunrise and sunset on a planet in another solar system.
But that planet is nothing like Earth. And most of these newly discovered solar systems are nothing like our own. Their planets are huge, much bigger than Jupiter. Some follow wild orbits. Some orbit in the opposite direction. And some shoot billions of miles out into space, then dive back toward their star. A few orbit so close to the star, their surfaces vaporize.
It's bizarre at the least, if not completely frightening. Planetary systems offer a wide diversity of different architectures, sizes, masses of the planets, and so on, rendering our solar system just one type of a planetary system out of thousands.
It could be that each and every solar system is a one-of-a-kind. But they all have one thing in common. Each one begins with a star. First, a star is born in a cloud of dust and gas called a nebula. This is the Eagle Nebula. These are the pillars of creation. And this is the Horsehead Nebula, an enormous star nursery. What scientists have been trying to figure out is what triggers the star-making process.
One possibility is that a nearby supernova explosion took place and rammed into this otherwise innocuous molecular cloud, smushing it, smashing it, compressing it down so that gravity could take over.
Once gravity takes over, the cloud begins to shrink, sucking in more and more gas into a giant spinning disk. Gravity at the center crushes everything into a dense, super-hot ball that gets hotter and hotter. Suddenly, atoms in the gas begin to fuse, and the star ignites. The leftover dust and debris forms a disk spinning around the new star. It contains the seeds of planets, moons, comets, and asteroids. In 2001, the Hubble Space Telescope was scanning the Orion Nebula and took this image of a young star surrounded by one of these disks. It's a picture of a solar system being born.
Whenever I look at these beautiful pictures of nebulae, the thing that really gets me is that these are baby pictures of our own solar system. We looked like that once.
These fuzzy images have opened the door to understanding how planetary systems form.
We have this marvelous first ever tool by which we can take pictures of planets caught in the act of formation. It's quite a marvelous opportunity for us to see the planets around other stars forming, thereby giving us a glimpse as to how our own solar system must surely have formed.
Scientists understood where stars come from, but not how planets grow from the disk of gas and dust. The answer was discovered by accident aboard the International Space Station. Astronaut Don Pettit was experimenting with grains of sugar and salt in the weightlessness of space. Stanley Love was watching from Mission Control when Pettit stumbled onto the process of how planets form from cosmic dust.
Well, one of Don's Saturday morning science projects was to take the bags that we store drinks in, and he put other stuff in it, like salt and sugar, and there was one bag that he just left the coffee powder in. Then he inflated the bags, and with these particles in them, noticed that the particles would just clump up immediately. They make a little dust bunny.
We'll be spending some time watching that.
Say, Don, this is incredible. You've just solved a 40-year-old problem in planetary science.
Astronaut Pettit had discovered something big. In the zero gravity of space, particles of dust don't float apart. They clump together. This is how mighty planets are made from cosmic dust.
The dust particles would collide and stick and grow into ever larger dust particles and eventually rocks and eventually boulders.
The bigger the boulder, the more gravity it has. It begins to eat up everything around it and grows bigger. It becomes larger, heavier, and consumes bigger and bigger rocks. Eventually, some of these rocks grow into planets. This is what happened in our solar system 4.6 billion years ago. There were about 100 young planets, all orbiting the new sun. Collisions were inevitable. At the beginning, solar systems are violent. Ours was no different. It began with about 100 small new planets. So, how did it go from 100 small planets to the 8 major planets of today? We got the answer by studying the evolution of other solar systems.
We see solar systems forming planets, and all of a sudden they have these giant disks around them. Those disks must be from huge collisions.
If planets are smashing together in other systems, they probably smash together in our own. We now know that all solar systems do this before they settle down. It's the way they're built.
The nice, neat, orderly solar system that we see today has not always been the case. In the early days, a few million years basically after the planet started forming, there were dozens, maybe even hundreds of these young planets that were bouncing around the solar system. They would smash into each other. Sometimes they would collect and get to be bigger planets. Sometimes they would smash each other and turn into little bits.
There was heavy traffic in the new solar system. Objects of all sizes. They were bound to collide. Some of the planets grew larger, and so did the collisions.
I like to try to imagine what it would have been like to actually stand on the early Earth and look up into the night sky. Things would have looked different.
Planet hit planet. Only the largest survived. The rest were smashed to pieces. Something very large struck the young planet Mercury. It blew the crust off and left behind just the iron core. And the young planet Earth did not escape either.
A planet-sized object slammed into the Earth off-center and blew a huge amount of the Earth's crust into space. The debris circled around the Earth and eventually coalesced to become the Moon.
This demolition derby raged for 500 million years.
What we see now, Mars and Earth and Mercury and Venus, these planets in the inner solar system, they're the survivors. They're the ones who lived through these giant impacts.
Debris from smashed infant planets ended up in the asteroid belt, a junkyard of rocky, leftover planet parts. Most of the big impacts happened in the inner solar system. But one of the outer planets, Uranus, was also hit and knocked on its side. A mystery, since the outer planets formed mostly from gas and largely escaped the violence of the inner solar system.
These rocky cores formed, the gas accumulated around them. This process actually happened very rapidly, in astronomical terms, in only about 1 million years. And those are the giant planets we see today.
Beyond the gas giants, Jupiter and Saturn, are Uranus and Neptune. These two are made of gas and ice. And beyond them lies the Kuiper Belt, a band of orbiting icy rocks and dwarf planets. We used to think that one Kuiper Belt object, Pluto, was the 9th planet. We've since decided that Pluto is in fact a dwarf planet, one of many, orbiting more than 3 billion miles from the Sun.
There are millions of these things out there. They're so far away and so faint that they're hard to see. These are left over from the formation of the solar system itself.
The Kuiper Belt marks the edge of the Sun's influence. There is no warmth and not much light way out here. But the Kuiper Belt is not the end of our solar system. A shell of trillions of icy objects called the Oort cloud is even further out. The Oort cloud is so far away, light from the Sun takes a full year to reach it. From the cold outer edge to the hot star at the center, our solar system seems stable. Everything appears orderly and in its proper place. But something isn't right. Uranus and Neptune are in the wrong place. The planets of the solar system grew from a giant disk of dust and gas. The 4 inner rocky planets close to the Sun, and the giant gas planets farther out. But Uranus and Neptune seem out of place. There wasn't enough stuff this far from the Sun to make such big planets. So, what are they doing out here?
That led us to a theory where Uranus and Neptune formed very close to the Sun and were actually violently pushed outward.
So what could shove 2 massive planets clear across the solar system?
We believe that Jupiter and Saturn got into this funny configuration where Jupiter went around the Sun exactly twice, every time Saturn went around once. And that configuration allows the planets to kick each other more as they pass one another. And that caused the whole system to go nuts.
The combined gravity of Jupiter and Saturn yanked hard on Uranus and Neptune and pulled them away from the Sun. As they moved outward, the 2 planets plowed through asteroids and other debris left over from the formation of the other planets. This sent billions of chunks of rock flying in all directions. Some rocks form the asteroid belt, but most were thrown out to create the vast Kuiper Belt.
The analogy I like to use is think of a bowling match. The bowling balls go down and the pins just go kaplooey. That's what happened in the outer part of the solar system.
The gravitational push from Jupiter and Saturn was so strong, it may have reversed the position of the 2 planets.
looks like it's possible that Uranus and Neptune actually formed in the opposite order. Neptune was closer to the sun than Uranus, but these gravitational interactions actually swapped their positions.
It was the blizzard of rocks that Uranus and Neptune ran into that acted like a brake and slowed them into the orbits they keep today. The idea of planets changing orbits may sound crazy, but scientists have seen it happen in other solar systems. So now, they think it's just the way all solar systems work.
When we look out into the galaxy and look at planets around other stars, we see lots of evidence of those kind of events happening elsewhere.
In one far-off system, scientists have spotted something completely off the charts. A planet as big as Jupiter, but it's not acting like the Jupiter we know.
Some of these giant planets are found orbiting very close to their host star, taking only days, a few days, to go around the host star. Obviously, such close-in Jupiters are blowtorched by the star, raising the temperature of the planet up to 1,000 or 2,000 degrees Celsius.
There's no way a gas giant could have formed this close in. It's way too hot. The only explanation is that it must have formed out there and then moved in here. The same thing could have happened in our own solar system. Scientists have found large amounts of the element lithium on the surface of the sun. Lithium doesn't normally exist in stars, but it is found in gas planets. Maybe there was another gas giant in our own solar system that spiraled in and crashed into the sun. That would explain how the lithium got there.
Something very violent happened. Could it have been one of these Jupiter-sized planets getting thrown in toward the sun long ago?
In the beginning, solar systems are violent and messy. But over time, they settle down and become more stable. But stability is an illusion. Any planet in the solar system is always in danger of total annihilation. There are all kinds of solar systems in the Milky Way galaxy. Most seem strange compared to our own. Some planets follow crazy orbits. Some smash into each other. Others dive into their stars. So, why are the orbits of our own planets so regular and stable?
Well, that's because all the planets have motion left over from the formation of the solar system. When the nebula collapsed around the sun as the sun was forming, there was an intrinsic motion, and that gave our planet a velocity. Literally, we are falling freely toward the sun at all times, but we're going so fast we keep missing it. That's what an orbit is.
Think of a merry-go-round. The faster it spins, the farther and farther you're thrown from the center. When it slows down, you lose momentum and fall back inwards. It's something like that with planets. The disk that gave birth to the planets was spinning, and the momentum left over from that keeps everything going around to this day. Moving at 66,000 miles an hour, the Earth takes 1 year to orbit the sun. Planets farther from the sun have bigger orbits, move slower, and take longer. Saturn orbits the sun once every 29 years. Neptune takes 164 years. Each planet stays on a precise path around the sun, and for us, that's a good thing.
Our solar system has a somewhat fortunate spacing of the planets with nearly circular orbits, which keeps the whole house of cards from falling apart, crumbling, scattering to the wind. If our solar system did not have nice, neat, stable, nearly circular orbits, the Earth wouldn't be here, and we wouldn't be here talking about it.
The planets are on safe, stable orbits. But billions of comets and asteroids are not. Many come streaking into the inner solar system. And when they do, watch out.
Meteor crater, which we see here today, formed as a result of a 150-foot rocky iron object coming in and slamming into the Earth roughly 50,000 years ago.
Some of the objects coming our way can be much bigger. Look at the moon. It's covered with large impact craters. Earth has been hit too, a lot. But the craters have eroded. We know that a huge asteroid smashed into the Earth off the coast of Mexico 65 million years ago. It was going 45,000 miles an hour, and when it hit, it released more energy than 5 billion Hiroshima bombs. It wiped out 70% of life on Earth. A few more impacts like that could destroy all life on Earth. But, believe it or not, Earth has a giant bodyguard.
Jupiter is more than just another pretty face through the telescope. It's actually really important for life on Earth. Jupiter's gravity is so huge, and it's just in the right place in the solar system, that it protects the Earth from comets that come from deep in the solar system and swing by the sun and could possibly hit the Earth.
Jupiter plays the role of the biggest baseball bat in the solar system. As these comets come by, most of them get knocked out of the solar system by Jupiter.
In 1994, comet Shoemaker-Levy 9 raced toward the inner solar system. But it never got past Jupiter. Astronomers watched as Jupiter tore it to pieces and dragged its remains down to the planet's surface.
We have seen comets smash into Jupiter, creating fireballs that were bigger than the Earth.
They were the biggest explosions ever seen in our solar system.
Had that comet hit us, it would have resurfaced the planet. It would have been the end of life as we know it.
If Jupiter wasn't there, we believe that the impact rate on the Earth would be something like 1,000 times more than we see today.
Lucky for us, Earth has the perfect orbit. Jupiter protects us from asteroids and comets. We're close enough to the sun for liquid water, but not so close that it boils away. It's just the right combination for life. Question is, if our solar system could create the perfect conditions, could other solar systems do it too? Planet hunters have spotted a solar system 20 light years away, and it has a planet just the right size in just the right place. Astronomers around the world are looking for new planets in distant solar systems. So far, they've discovered more than 420. Most are huge gas giants like Jupiter. But they're either very close to the star or much farther away. Then, in 2005, astronomers made an exciting discovery. They detected a solar system with rocky planets like our own. These planets orbit a star called Gliese 581.
This star, Gliese 581, and its 4 planets is frankly quite bizarre relative to our solar system. The 4 planets we know of all orbit very close to the host star, all 4 of them orbiting closer than the planet Mercury, our closest planet, orbits the sun.
But Gliese 581 is a small star. It doesn't burn as brightly or give off as much heat as our sun. So the planets can orbit much closer without being vaporized.
We know of 4 planets going around this star, and a few of them are quite interesting. There's one that's only about twice the mass of Earth. Now, that particular one is very close to the star. It's probably very hot, too hot for life. But there's another one, about 8 times the mass of the Earth, which is getting far enough away from the star that it might be in the habitable zone.
Like Earth, this planet orbits at a distance where water is a liquid. And where there's liquid water, there could be oceans and life. In March 2009, NASA launched the Kepler Space Telescope. Its mission, to search for planets similar to our own in new solar systems.
We may find planets that have methane atmospheres. That have ammonia atmospheres. We may find planets that are covered in heavy organics, a tar-like material. We may find some that are covered by water. I think one of the glorious quests here in the next decade or two is to learn the full diversity of the family of Earth-like planets that may be out there in the universe.
With Kepler, astronomers expect to discover hundreds, possibly thousands, of new solar systems.
Think about our own Milky Way galaxy. The galaxy has roughly 500 billion to a trillion stars. Some fairly large percentage of that have planets. Now, think about how many galaxies we know of. We certainly haven't found all the galaxies in the universe yet, but the ones we can take a picture of are actually about 60 billion galaxies. When you look up at the night sky tonight, simply in the path of your sight, even if you can't see it, there are billions of solar systems all around you.
And there could be a solar system with a planet just like Earth. If it happened once, it could happen again. Solar systems don't last forever. Orbits fall apart. Planets collide. It might happen to us. But even if it doesn't, in another 5 billion years, a catastrophe will end our solar system as we know it. Nothing lasts forever, not even solar systems. Ours may seem stable now, but actually, it's very slowly coming apart.
If the solar system was chaotic in the past, that doesn't mean it's all settled down now. There is still a possibility of a little bit of chaos in the future.
In the future, the gravitational pull of the planets on each other will gradually disrupt their orbits.
Perhaps over the billions of years, the planets will jostle each other in this gravitational way, so that eventually 2 of the planets will come close to each other. When that happens, and it will, those 2 planets will engage in a sort of do-si-do, flinging one or the other of them, maybe both, into wild orbits, perhaps ejecting one or both of them from the solar system.
Mars could be thrown out of the solar system, and Mercury might crash into the Earth.
The entire house of cards that is our solar system would completely fall apart.
Solar systems begin and end with a lot of collisions and destruction. But don't panic yet.
This is going to take billions of years, but over the lifetime of the solar system, these are eventualities that could come to pass.
But one way or another, our solar system is doomed. Like all solar systems, the end will come when the star at the center dies. In 5 billion years, our own star will run out of fuel and become a red giant. It'll heat up, swell, and engulf the inner planets. The Earth's surface will be scorched. The seas will evaporate, and the land will melt.
The sun will become about as big as where the Earth's orbit is. So a likely scenario for the end of the world is that we're going to be inside the sun for a while.
The Earth's going to get swallowed right up into the sun, and it's going to be toast. Vapor, literally.
After a while, the red giant will fall apart too, leaving behind a tiny corpse of a star called a white dwarf.
It'll be about the size of the Earth, and it will cool off over many millions or billions of years. That will be the real end of our solar system.
From the Earth, this dead, rocky planet that used to harbor an enormously vibrant civilization, we will look out, and there will be this fairly faint dot, which is our sun, now a white dwarf, a dying, almost dead star.
The remains of the inner planets will continue to orbit the white dwarf. But the giant outer planets will live on, untouched.
They will have warmed up during the red giant phase of the sun, but once the sun is a white dwarf, those giant planets will survive just as well, holding on to their hydrogen and helium, albeit colder than they used to be, because that white dwarf will no longer be warming them up.
Even though this is 5 billion years in the future for our solar system, it may already have happened to many other systems throughout the universe. Our solar system emerged from chaos to eventually support life. We were lucky. We've just the right amount of planets, in the right place, at the right distance from each other, all orbiting the right type of star. But it could have been a very different story.
There are so many things that are fortunate about our solar system, starting with the sun. The sun is a very stable, easy star, a perfect thing for life to evolve around. That's probably not a coincidence that we're here.
An extraordinary chain of events over billions of years have made our solar system the perfect place for life to evolve.
What we see today is not the way things have always been, and not the way things will always be. We're not unique, but it is just the way things worked out.
The Earth has to be in the right place. The planets had to be in the right place. The giant planets have to be in the right place to protect us from impacts. All that has to be right in order to get life on Earth.
Ours is the only planetary system we know that supports life. As solar systems go, does that make us extraordinary or perfectly normal? We don't know. But every week, we're discovering new solar systems with new planets. It could be just a matter of time before we discover we're not alone.